Name that tune. Hello and welcome to Math Monday number 9. What am I gonna do in 2 weeks when we're at number 11? Haven't thought that far ahead. Some of you know it's the stampede going on right now. I've been to it a few times already, mostly for live music, and last night standing next to a speaker got me thinking a lot about sound and the kind of effect it has on me and sound intensity. So I'd love to talk to you guys about sound intensity and the mathematics behind that. But in order to do that, I need to make sure we all are on the same page about logarithms. Some of you might have an idea of what I'm talking about right now. Some of you might just think I'm speaking gibberish. Logarithm is a mathematical concept and it's actually not too bad. Okay, so let's just do a quick little review of what exponents are, because if you want to know what a logarithm is, you need to know what an exponent is. So for example, an exponent is just telling you how many times you should multiply a number by itself. So 5 squared is just saying multiply 5 by 5. So we're multiplying 5 2 times. 5 times 5 is 25, right? Another example, say we had 3 to the power 4, it's saying multiply 3 4 times. So it's 3 times 3 times 3 times 3. That's 81. You can keep going. Obviously, you could do really big exponents. This is why exponential growth is known as something that grows really, really fast, right? Because you're not adding every time, you're multiplying every time. So 4 to the power 6 is 4 times 4 times 4 times 4 times 4 times 4. I got it enough times. That's 4,096. So what logarithms are used for is when you don't know what an exponent is. So you have the base and you have the answer, but you don't have the exponent and you don't know what that is. So if I flipped it around and said 4 to the power of x, x representing an unknown, is 4,096. Well, I'd use a logarithm to figure that out. It'd be x is equal to the logarithm of base 4 of 496. Okay, sorry, 4,096. Have I been saying 496 this whole time? Oh my goodness, I'm sorry. 4,096. We can use a calculator to do that. Obviously, we don't need to this time because we already know that 4 to the power 6 is 4,096, but you can. So here's how you'd use it on my calculator. I can actually put in the base. A lot of calculators you can't put in the base and they just do an automatic base 10. And so in order to do logarithm of base 4 of 4,096, all you need to do is you take the logarithm of 4,096 and divide by logarithm of 4, okay? And look at that, it still gets 6. So again, that's assuming that you're in logarithm base 10, which we're not always working with base 10s. We actually will be when we're working with sound intensity. So there's some rules to logarithms that actually make it really useful when you're trying not to use a calculator, because they simplify it into something where you can actually figure out the answer in your head and not on a calculator. So the first one is just generally the logarithm of base a of b plus logarithm base a of c is the logarithm of base a of b times c. Okay, so you just take those two numbers and multiply them together. You need to have the same base for this to work out. So, for example, say I had the logarithm base 6 of 3 plus the logarithm base 6 of 72. I don't know 6 to the power of anything that would equal to 3. I don't know 6 to the power of anything that equals 72, right? 6 squared is 36. 6 to the power of 3 is 216, so this isn't going to work for us. So what if I bring that into one logarithm? That's logarithm base 6 of 3 times 72, which is logarithm base 6 of 216. Oh my goodness, I know that. 6 to the power of 3 is 216. So therefore, that's equal to 3. If we want to double check that on the calculator, you can. All right, and as you can see, we still get 3. Second one I want to talk about is the division one. So basically it looks the same as the one before, but instead of adding, you're subtracting. Okay, so what do when I'm subtracting two things with the same base? I divide those two things. So that's the logarithm base a of b divided by c. Okay, so again, it's going to be useful in the same way that it was in the first one. So say I had logarithm base 7 of 147 minus the logarithm base 7 of 3. Again, I don't know 7 to the power of anything that's equal to 147, or if I can take 7 to the power of anything and get 3. At least not a nice whole number. Nothing's coming to mind. So let's divide those. That's going to be the same as logarithm base 7 of 147 divided by 3, which is 49. 7 to the power of 2 is equal to 49. You should know that. You should know your perfect squares. They're pretty important. So that is equal to 2. Again, if you want to double check, you don't trust me, let's put it into the calculator. Let's even go ahead and put the original question into the calculator. Log base 7 of 147 minus log base 7 of 3. Look, we get 2. Isn't that amazing? So I promise I'm not leading you in the wrong direction here. This is what it equals. So these are fantastic rules for situations like that, when you have numbers that you don't really want to work with, and then it simplifies into a number that you can work with and you can do in your head and not necessarily with a calculator, as much as possible. There's a third rule that when we're just working with numbers, it's not as useful. This is going to be more useful when there's, again, an unknown in the exponent and you can't find it, okay? So that is that the log base anything, doesn't really matter what the base is, of b to the power c is the same as c times the log of b. Okay, so I just kind of brought that exponent out front and I'm multiplying it by the log of b. So for example, say I had log base 4 of 256. That's actually equal to 4 because 4 to the power 4 is 256. I'm sorry, I kind of just spoiled it for you. But there's another way to get this, because we can also think of 256 as 16 to the power of 2. So what if instead of log base 4 of 256, I had log base 4 of 16 squared? Well, that's the same as saying 2 times log base 4 of 16. Log base 4 of 16, well, 4 squared is equal to 16, so that whole thing is just equal to 2. And all we have is 2 times 2, which is 4. All right, so that's just the general rules of logarithms, things like that. I know not super interesting today, but that's the thing about math, is sometimes you have to take things that are just calculation based like this, and then what they apply to is really, really interesting. So from here, I can apply this to sound intensity, the Richter scale, so many different things. Anything that uses exponential growth or decay, we can also use logarithms for. So there's actually so many applications in real life for logarithms. Anyways, that's it for today. I hope you guys are having an awesome summer so far. Have a great week, you guys. I'll see you next week when we talk about sound and sound intensity. I can't wait. Bye.